the group. Please can we just unmute our mic? Let me hear at least a word from any of us. As a word.
Good evening, sir. We can hear you.
Yes, thank you very much. Yes, I can hear you. Yes, others. I'm the Samad, Usman, Esther, my G, and Chine. Let me hear your voice.
Good afternoon. Yes. Good afternoon, everybody. Good afternoon, Mr. Sadiq.
Good evening, sir.
Esther, how you doing? I'm the Samad. Good afternoon. How you doing? How has it been so far? Well done, people. Chineye, are you still here?
Well, it's been fine. It's been going well.
So how have you been coping in this economy?
This economy is not
economy.
It's not what's it called? It's not going smoothly, but thank God, thank God.
Yeah. Usman. Usman, let me hear your voice. All right. So good afternoon. Good afternoon. It's good to hear your voice. And possibly, I know before we wrap up for today, I should be seeing your faces. Yes. All the fine faces. Yeah. So good afternoon, everyone. So I'll try as much as possible to be not to take much of our time. So, but here this afternoon, we are here to discuss about data modeling. So we're talking about data modeling. And generally, when we talk about data modeling, we're talking about how we can structure our tables. So there are some concepts that we need to understand when it comes to data modeling. So just pardon my slide today. This slide, I just prepared it right now here on this seat. So, but then I'll try and make sure that we understand the concept of data, what the real aspect of it. So the slide, you can always explain it. Now, when we talk about data modeling, so we are basically talking about how we can structure our table such that the table is well arranged and our analytics is perfect. And the goal of data modeling, there are just two goals for data modeling. Once you know this, at least you will understand why we need to model our data. So number one is in order to model our data, one thing that we have in mind is we intend to reduce redundancy. We are looking at reducing redundancy in our data. That's one thing. And second thing is we want to improve the efficiency of our data as well. So those two points are critical to modeling our data. So let's now talk about it. When modeling our data, we're talking about the process of organizing and structuring your data based on relationship. And the key word there is we want to improve efficiency, and we also want to reduce redundancy. And when you model your data, then eventually you find out that eventually you are going to be having multiple tables. This is an example of a modeled data. And when modeling your data, what are the importance of modeling your data? Number one, you are interested in what? You helps you to organize your data efficiently. So you find out that your data is going to be efficiently organized. And once that is done, you will be able to create an accurate report. And eventually, because you have modeled your data, you've put what needs to be on the fact, what needs to be on the dimension, you find out what you maintain the integrity of your data remains intact. And as we have said earlier on, is that what you reduce redundancy in your data. So you are not collecting the same data multiple times. And eventually, when you're not collecting the same data multiple times, you find out that what the efficiency of the performance of your system is well improved. Because with the moment you model your data very well, number one is that what when you may instead of you having about 25 million data, because you have modeled it, you end up having what about 15 or 13 million data point that you've collected. Now imagine you have in a table, you have 13 million. In another table, you have about 25 million rows of data. Tell me, which of these table, in terms of performance, or in terms of performance, yes. So which table will load faster? Which table will load faster? We all will agree with me that what? The table with the fewer data points tends to load faster compared to the one that has what? A higher number of data points. So that's why we say what? It improves the efficiency and performance of our system. And finally is what? It is very easy when you're not doing your report. It makes it very easy to create your calculated column and your measures generally. So as a result of modeling your data, it becomes very easy to create your measures. And when we talk about modeling your data, there are different aspects of modeling your data. Eventually, you create a schema. And when we talk about schema, there are two aspects of schema that are very important. We have something that's called the star schema that you all are used to. And when we say the star schema, so when you the types of schema is what we call the star schema. And this type of schema helps you to break your tables into two categories. You're going to be having two categories of table. The first category is what we refer to as your fact table. It is what is referred to as your fact table. And on your fact table, basically, it contains the key metrics of the business. Your fact table contains the key metrics of the business. We're just going to run through the explanation here. Then we will see it in real time how it works in data. Now, it contains the key metrics of the business, just like your sales, the quantity that was ordered, the profit that you made, the discount that you give, and every other thing is what is referred to as what is what you will have on your fact table. And the second category of tables that you're going to be having is the dimension tables. What does dimension tables does? It's what is a table that describe what your entity. It gives context to whatever your data. So the type of dimension table that you can have is you can have a table that speaks generally about your employee. So that contains all the details of your employee. So we call that one the employee details. So it is a dimension tables. Another table that we have that can also have is your the table that contains information about all your outlets, your business outlets, or we can call it the branches of your business. So it's also what a dimension tables. Or you have another table that is talking about the type of products that you sell or services that you render and the subcategories that we have under them. So those tables, all these tables are what we refer to as the dimension tables. The dimension tables. And eventually, when you are dealing with your star schema, you're going to be having just one fact table. Star schema always has just a single fact table. Then you can have as many dimension tables as possible. You can have as many dimension tables as possible. Then you can now start creating relationship between your fact table and your dimension table. So the arrangement of this thing is what actually gave it to the name. So it is arranged in a star form. So if you look at the picture you have on my screen right now, so in a star form, so that's why we call it the star schema, whereby all your dimension tables can be what they are connected, they are linked to your fact table. And another thing we need to note there is for each dimension table is a separate table on its own, and it has a unique identifier. Each dimension table is a table on its own, and it also has a unique identifier, something that we use that we can use to identify every other thing on that table. And that unique identifier is what is referred to as the primary key of that table. The unique identifier is what is referred to as the primary key of that table. So for instance, your employee table that contains all the information about our employee. What information are we looking at? We are looking at the employee name, the email address of the employee, the department that this employee fall into, the dates that this employee joined our organization. Right? We can also talk about under the we can talk about the role of the employee. We talked about the role. We talked about what other information. Every other information, that's the marital status of employee. But all this information, there's something that you need that can you need something that can uniquely identify each employee. So in some organization, they use email address to identify. While in most organization, they have employee number, such that because in a single organization, we can have as many possible as many people bearing Sodiq Yusuff, but it's very impossible for two employees to have the same employee number. So that number is what we use to identify each employee. When we say let's say our structure of our employees, like we say D, then iPhone, the five digit number that follows it. You will notice that those 5 digits can never be the same for all employees. It's going to be different. So that digit, that employee number is what we use to identify. Just for example, now today I went to the hospital and went to the hospital to just check myself out, and my HMO is Avon. So regardless of your name and where you're coming from, Avon is going to assign a unique identifier to you. In this case, they use what? AVH as their what? As their they use AVH, that's 3 digits, followed by your organization name, and they now assign a 5-digit code to you. So even if they have 1 billion customers, my own unique code can never be the same as any other person. So if they need any information, and they need to do this, when I get to that hospital, what they need is what? My what do they call it? HMO number. They can use that to get every other information they need about me. Right? So that HMO number is what is referred to as the primary key, because it is unique to me alone. So each dimension table has a primary key, right? And once you have that primary key in your facts table now, for you to be able to connect your dimension table to your facts table, that primary key you are going to be having each table is going to be having a representative on the dimension, on the fact table. So your fact table is always combination of all the primary keys I have on each of the dimension tables. Let's say we have 5 dimension tables. So we're going to have 5 different primary keys on the fact table, and with the values, which are the key metrics of the business. Right? Now, this your primary key. For instance, on your employee table, your employee number is a primary key. But this same employee number, which is the primary key, once it appears in any other table that is different from its own base, its own table, which is the employee table, then when you get to any other table, that is when we refer to it as a foreign key. We refer to it as a foreign key. So foreign key simply means a primary key that is in another table. Primary key of a particular table that cannot be found in another table. So for those of us who do SQL and the likes, we deal with this the most. So same thing, all these things are the same across board. Same thing, this same primary key and foreign key that we are talking about. When you get to Excel, it is the same thing that we refer to we use in VLOOKUP. So it is referred to as your lookup value. Your lookup value. So which is the value that is common to both tables that you want to extract information from. So that is very important. So all these things across board, they are still the same thing. Once you understand the concept, you'll be able to use it across any tool that you're working with. right? So that is primary key and foreign key. So that's what explain what the dimension table. That is so under with the star schema. So you now see your dimension tables connecting to your fact table. So another example of schema that we have, which is also very common and not so common, but what is also a schema is what we call the snowflake schema. The snowflake schema. So snowflake schema is just like your normal your star schema. Just that what the difference there is for star schema, for what do we call it? For star schema, you have a single fact table, just one fact table that are connected to different dimension tables. Right, that's one. But in terms of the snowflake, you can have more than one fact table. That's one. You can have more than one fact table. And secondly, instead of your dimension table connecting directly to the fact table, then you can have one dimension table connecting to another dimension table before that one will eventually connect to the fact table. You have a dimension table connecting to another dimension table, then that one now eventually connect to get to the fact table, right? And this table, is it my network? Please confirm that you can hear me. Can hear some, since my Teams is making a sound. Can you hear me? Please confirm. Hello. Come again.
We can hear
Yes,
you
sir, we
now.
can
We can hear
hear
you
you.
now.
Oh, all right. Oh, you lost me for a bit, right? Okay,
Yes,
so I was
just
talking
in a
about
few seconds.
snowflake. I said snowflake is just, yes, it's just like your star schema. You know, in your star schema, just like I explained earlier on, your star schema means what? You have dimension tables connected directly to your fact table. And under the star schema too, you're only going to be having just a single fact table, a single fact table that will be connected directly to all other dimension tables. But in terms of the snowflake, you can have more than one fact table. You have more than one fact table, but one thing that's very common to them is your dimension in star schema, dimension table connect directly to fact table. They don't connect to any other dimension tables. But in snowflake, you have your dimension table connected to another dimension table before that one will now eventually connect to your fact table. So you have one dimension one connected to another dimension. Then the second dimension now connect directly to the fact table. So that is what we call the snowflake schema. And it is more normalized. It's a complex schema actually. It's a complex schema, but it's more normalized than what? Than the star schema. So let's see it in terms of diagram. So we see how a typical snowflake schema, a typical star schema will look like, and how a snowflake schema will look like. So the first big diagram you are seeing on my screen on the left hand side is a what is for the star schema. You can, as you can see, we have different dimension tables, but they are all connected to a single fact table. They are connected to a single fact table. But in terms of the snowflake schema, you see that what we have a dimension table. Look at it. For instance, now this is location table, which is a dimension table, right? We in there we have the location ID and the region. Now this table now is a dimension table. It is now further connected to another dimension table, which is the dealer table. Now this dealer table now has dealer ID, location ID, which is coming from the location table, country ID, the dealer NM, and so on. So now we have dimension table connecting to another dimension table. Now this new dimension, second dimension table now can now connect to the fact table. So anytime you have dimension connecting to dimension before you get to the fact table, that is what we refer to as the snowflake schema. So we can see the country as well. We have a separate dimension. So it's actually a complex table. It's a complex dimension table. So we have where we have multiple dimension tables. Here now we also have another country table, a table called the country table, connecting to the dealer table. Then where if eventually connect to the fact table. Down here as well, we have the variant, connect to product, then connect to the revenue, the fact table. So this is what we call what? Example of a dimension to a snowflake schema. A snowflake. Now we can see the difference between a snowflake schema and a star schema. Star schema connect your dimension table directly to the fact table. While in terms of the snowflakes, you have your dimension connecting to the fact table. Then you have your fact connecting to the dimension. Okay, I think I'm back now. All right, my network is terrible this afternoon. What's going on? All right, now let's now talk about the models. Let's talk about models of the tables. Now, when we're talking about models, we have two different types of models. We have something that's called the normalized model and the denormalized model, or you can call it a table. Now, when we talk about the denormalized model, let me start from there. The denormalized model. Now, here we are talking about a model that has what? We're talking about a model that has all its column on a simple table. We're talking about having what? Where you have all your models, all the columns of your table on a simple table, on a single table. So you have the combination of all the facts and all the attributes all on a table. But when we now talk about the normalized model now, we are talking about you having that big table now, okay? That big table, I'm going to use this data as an example. Bring it up. Now, looking at this table that I have is a sales table where I have my sales number. How many columns do I have here? Let me check. I have about 21 columns, right? Now I have just a simple table that is very big. A single table, a very big table that contains all our data points. Everything is in a simple table. So this type of table is referred to as a denormalized model. But in a case, when you look at this table very well, we can find a situation whereby there are some columns that keeps repeating itself, which are not meant to be. So those type of column, we call them the redundant columns. Instead of having them there, we can actually reduce these columns from 21 to a very smaller table. Then we can have what? We can now what? Connect them. So when you now break this big table into a smaller table, that only was that, so that has its own, it tends to reduce repetitiveness, tends to reduce redundancy in my data. Then such model is what is now referred to as the normalized model. Now let's take a very good look at a pictorial example of this model. Now, for instance, the denormalized model has all the columns on a single table, right? For instance, here we can see we have the product key, we have information about product, We have the sales order number, the order date, the product key, product itself, the product name, the category of the product, the color of the product, and the size of the product. Then we talk about the reseller and the salesperson. Now, in this denormalized table, you can see that about 4 or 5 different columns are repeated, which is that they all contains information about product, which are the product key, the product name, the category of the product, the color of that product, and also the size. Instead of you having all these columns that are called the redundant columns, because instead of you having about all these 5 columns on the same table, when you try to reduce the number of columns that we have in this table, you only retain only the unique key, the unique identifier for products. We don't need all the product information on our transaction table, which is also the facts table. So we only need the unique identifier of a product on that table. Once you have that, it will be able to get every other information. You can get it using that unique key. So the moment you now break down your table into such table that only has you've not done away with all irrelevancies on your table. You, instead of having all the columns, you only have the key to that product, which is a unique identifier. Then that table now becomes a normalized table or a normalized model. Then you now have all your beside. Now the big question now is, when you have a denormalized model or table, just like I have on my screen here, how do you normalize it? Because, for instance, now I just say, let me show you the disadvantage of having something of this nature is in this table now, I've said how many columns do I have? You count it, I have 21 columns, right? Then let's check how many rows of data do I have. So from here now, shift down. It tells me how many rows. I have 7,991 rows of data. Or I can do control row down to see the end. You can see 7,991 rows of data. If you remove the heading, you have sent at 991 rows. Now, this now, so if I go up and say, okay, so I have 7,991 rows of data. So if I'm meant to calculate the total data points that I have, data points, which means this figure is a data point, this is another one. So if I need to count them one after the other, so it's going to be like equal, I'm going to multiply my number of columns multiplied by the number of rows of data that I have on this table. Then, sorry. So now it is telling me that I have 161. Sorry, somebody. Okay, I have 167,811 data points. Now let's now assume that these columns keep increasing, right? If it keeps increasing, let's say instead of 7,000, skip. Okay, instead of having this 7,991, it has now grown up to what we have 100,000. What will our data points be? You see, we have we'll be having 2.1 million data points. That which means when you're loading your data, you're going to be loading about 2.1 million at every point in time. Let's now say this one now again. Our data, because we keep making sales, people keep coming, our transaction table keeps growing, and that's the fact. It keeps growing every now and then. Now imagine we now have up to 1 million rows of data. Right? How many data points are we going to be having? We're going to be having 21 million data points. 21 million data points. This is for what we call the denormalized table, because our table contains all columns. Now, let's now say we want to normalize this table, this model. When I want to normalize it and say, instead of having 21 columns, we've done a lot of things and we have reduced this column drastically to up to, let me say, 13, for example. We now have 13 columns. And then now we have about what do we have now? The 1 million rows of data. Let me bring it there as well. I bring it there. What will be the total number of data points that we have at that point now that we have normalized it our table? You'll find out that what now our data is now going to be in what 13 million records. We only have what 13 million data points. Now tell me which one do you think will load faster from 21 million records to and 13 million? We agree that what that of 13 million will load faster. Now, what does that do? It has now we have improved performance of our data. We have improved the performance by what we have saved about 21 to 13. That's about 8 million records. By just what? When you subtract, we have 8 million records. So by just normalizing our table, we have saved ourselves 8 million records. Now imagine this table keeps growing just like banks. We have billions of data points. By the time you're having 13 billion, this is going to be just like what? This is going to be 21 billion, which is far, far, far more than what we have. So that is the essence. I remember when we were talking about the importance of modeling our data. We say what? It helps us to reduce redundancy. We have seen that, and increase the efficiency. So because it is not going to take lesser time to load our data, so we are now what? We're increasing the efficiency of our data among other importance. So now the big question is, if you have this kind of table, which is a very big table, which is a denormalized table. Why do I keep mixing them up? A denormalized table. So the big question is, how do you now model your data? How do you model your data? So in order to model your data, there are some certain steps that needs to be followed. Certain steps need to be followed. And these steps, once you can conveniently follow it, you master it, then you will be able to normalize that table, that big table. It becomes very easy for you to normalize it. And once you are able to normalize it, then you increase the efficiency of your model. You increase the efficiency of your model. So that will now take us to the next steps. The next step that we want to talk about, which is the steps in data modeling. What are those steps that you take in modeling, in accurately modeling your data? Now, importantly, there are 5 different steps that we must take. 5 different steps that we must take, and we are all going to do it together. Then we see how efficiently this is going to help us. Now, again, let me come back to this table. We say we have 21 columns, right? Now, let's now take step one after the other. Now, the first step of modeling your data is that what? You should identify all the fields in your data. Okay, let me come here, put it down in Excel. You can see step 1. We have 5 steps that we need to take. So yes, these are the 5 steps. Now, what is step 1 saying? If we come back to our screen, step 1 is saying you should identify all the report fields. all the report fields. So we already have a denormalized table, right? We now want to normalize it so that what we can improve the efficiency of our work. So identifying all the report fields simply means all the headings in your data. All the headings in your data, you should identify them. So I'll copy this, go to the next sheet. So for step 1 now, I am going to identify all the fields, put it there. Now these are all the report fields that I have in my data. So all the fields simply means what? All the columns that you have in your data, because that is what we are going to be dealing with. Now that we've done step 1, so let's see what do we have in our second steps. In our second step, the second step is now saying that what you should now categorize this field that you have in step 1 to either a report line, or you can call it a value. You can call it either a report line or you call it a value. So based on the data you have there. And when we say a value, value simply means any column in your table that contains number. That's the first condition. It must contain number, and secondly, you should be able to what? Aggregate it. You should be able to aggregate the number. Simply means aggregation means number one condition is that column must be a number. Secondly, you should be able to perform some mathematical calculation on it, and eventually the result of that calculation should be insightful. You should add insight into your data. You should be able to make a meaning out of your calculation. Should be able to either add it together, add the numbers together, multiply it together, you do anything that has to do with mathematical calculation. So you need to identify that. Now, on my data now, let's now identify for everyone. Once you identify values, every other column in your data is going to be referred to as the report line. So value is just something you need to understand. Once you understand that, every other thing becomes your report line. So let's please drop in the chat. This is what you can see on my screen. If you want me to scroll to the right and the left, let me know. Drop in the chat what are the values that you as a person can see on my screen. And I'm going to be sharing this
Can
data
you
with you.
zoom it in a little, sir?
Thank you. Okay. So let me zoom in. Okay, this is from the beginning. Whether the ship date, customer index number, the customer name, channel, the currency, yes, the delivery region, the suburb, the city, we have postal code or the postal code, we have the longitude, we also have the latitude, right? Then we have the full address. Okay. We have the product description index, the product's name itself, the quantity of product that we're buying, the unit price, the price per one, and the total unit cost, because the cost price, then the total revenue that we are making from this product. So drop in the charts. Let me go and see our charts. Which column do you think should be the value? Remember I said value contains what? Number, and those number, you should be able to aggregate the numbers. Okay. Okay, do you have to say quantity, unit price, total unit cost? Okay. All right. Okay. Interesting. Yes, any column that contains number, that's the first condition. And secondly, now is what? The number you should be able to aggregate the number. So if it contains number and you cannot aggregate the number, then it is not a value. So I can see what people are dropping in the chat already. Well done and thank you very much. Yes, our value here are the quantity, the unit price, the total unit cost, and the total revenue. The total revenue. So they are the key metrics of the business. So these are going to be our value. So every other column then can be referred to as the report line. So I'll come to my step 2 now to make it easier for myself. Let me quickly create a data validation to it or to VV. Data validation so that I'll be able to pick an option. And for the Excel guru, I use to bring up the data validation. I just use the shortcut is Alt AVV, report line or value. Alt AVV was what I used. Yep. So we have said our quantity is a value. Then unit price and others are all values too. So and then say okay, these are values. While every other one, they are all going to be referred to as the report line. The report line. So this is going to be our that is step 2, the second step. Now the third way of knowing how to do of modeling your data is that what? Now all your reports line that you have in step 2, you need to group them based on natural hierarchy. What this simply means, look at them and check, does any of this column, any of this column, do they actually what resemble? Are they talking about the same thing? Do they mean the same thing? So columns that are talking about the same thing, for instance, you have the employee name, employee number, employee name, the employee gender. All those 3 columns are talking about if they are giving us information about employee. So by default, they should be grouped. They should be in the same group. They should be in the same group. So same thing again. You have product ID, the product name, the product group, you have the group product name, the product ID name, the grouping of the product, and the category of the product, segmentation of the product. Then all those information are talking about what? Product information. Then they should be grouped into the same category. So that's what step 2 is talking about. That what? Check your, and please, you need to take note. It is talking about what? The report line alone. Your report line. So we have nothing to do with our value. So we go to the report line and check all this report line, which ones are talking about the same thing. Now, number 1 is, well, let's start from the order number. The order number. Okay, we have somebody waiting. The order number. So is there any, when you look at this, is order number related to any other column that we have here? This is stuff like when you order any product and the order ID or the tracking ID, like I used to track your order. Yes. So when you look at it critically, orders is standing alone. And there's nothing that says a column that cannot stand alone. So we look at orders. So orders is standing alone. So we should have in step 3 now, we should call it the group 1 as a standalone. Ship dates and order dates, they are talking about the same. They're all talking about dates, right? So we call them the group 2, right? We are grouping them. Customer index, customer name index, the customer name channel. So you need to check the column, what the column is talking about. We have the customer index, the customer name as well, right? So this index is less like the unique identifier. So anywhere you see 28, there means this is name that should record there. So let's confirm that. Let me go to 28. It should just be for that name alone. And you can see it's for Dama Limited. This is for these people alone. So if I come to the name is the same all true. Yes, interesting. So which means what? This is a unique identifier for the name, right? The customer information. So When I get to my step 3 now, on this, I can call this one now. Name and index belongs to the same group. So we call them group 3. That's another group entirely. That's another family entirely. Channel. These are sales channel, right? So how are we so what are the channels that we have? We have this distributor, the exports, and the wholesales, right? So is it related to anything? Is it related to currency, to the warehouse, to anything? No, it is standing alone. So we come here and see channel can now be our G4. And if you check currency, and this is current, these are the current different currency of transaction. So currency 2 is standing alone. The warehouse code. The warehouse code. So this information about the warehouse. So we have different warehouses. In fact, let me see how many warehouses we have. We have 1, 2, 3, 4, 4 warehouses. And these are the code that we use to identify our warehouses, right? So do we have any information about the name of the warehouses there? We have warehouse code. This is region. Talking about location. No, we don't have that. So warehouse code can also what stand on its own. This is G6. G6. Then the delivery region index. Delivery region index. So if you check from delivery region index, the suburb, the city, the postcode, the longitude and latitude, then we also have the full address of that customer. So all these 6 columns are talking about the same thing. So once you have the index of the what? The region index, which is unique code. So it's simply, once you have this index, you know the suburb, you know the city where it is coming from. Once you know the city, you know the postcode, longitude and latitude we can use to easily plot on our map, give us the exact location, the geolocation on the map, and we now have the full address. So therefore, all these 5 or 6 columns will belong to the same group, the same grouping. So we downward down to where we have the address. That will now be my group 7. Right? This is because they are talking about the location. Location. Then again, let's go. And the last one now is we have the product index, which is unique identifier of our product. If I go to index 7, then you have just one product there, which is product 7. It is identifying just the product 7. If you go to index 4, you should identify just one product, which is product 4. So these two are the same. They are all giving us information about the products, right? Then we can now go here and say these two are talking about the group 8. And if you look very well, we have exhausted all the report keys, right? Now, we now move on to, so the remaining ones are the values, so we can leave values out of it. We are dealing with the report key. Now, the 4th step that you need to also consider now is what? Is to identify the primary key of your table. So for each group now, we need to identify the primary key. And when we say the primary key, remember I said what earlier on? Primary key means the unique identifier of each group, that once you have the information about this particular one, then it can give you every other information you need on that particular group. So that is what it is referred as what? The primary key. So for tables that are standing alone, then they have to be their own primary key. So customer name is standing alone, but to add to bring it, no other family group. Now on the order date and ship date, right? So this is a date table, right? So we can use the order date as the primary key. But normally what we do is what we can further break down this date, right? But let's go on. Primary key. Then ship date to, okay, let's go. Then ship date is actually a date. Then it should somehow it can stand on this. We can actually put it there. But let's go. We have the reason why I'm talking about this is because this is the date. So basically, when we are doing analysis, it's always advisable that what you create your own date yourself. you create your date. So we will definitely create our date ourselves. So because on this date now, it is possible that what there is a particular date that the transaction or this thing did not occur, and that is going to be. So we should have a proper calendar. If you are talking about 2022 or 2024, you should have data from 1st of January of that year down to the 31st without missing anything. But let's proceed. Now the customer index and the customer name index and the customer name. So once the index means what? The unique identifier. So once we have the index, it is possible to have customers that bears the same name. But index is the unique identifier that we are using to identify each customer. So our what's it called? Our primary key, sorry, primary key, our primary key now, let's call it PK. Yes. Yeah, PK. So it's now going to be the customer index number. So once we have that, then we can have the information about the customer. The channel, since channel is standing on its own as well, we can have channel as well. Channel is standing on its own, the currency standing on its own, the warehouse is standing on its own. All of them we have what? Since they are standing alone, they can have their primary key. Now we have the delivery region index, the suburb, the city, the postal code, the longitude and latitude, and we also have the full address of the home. So you need to check which of these is unique. In fact, for me, I will be doubting, is it going to be the region index, or is it going to be the postal code? So we can actually check. So for instance, now, for me to check now, I can just highlight all of them, copy is the easiest way. And we're still doubting, right? So we come here, paste it, Control V. Yes. What do I have? Okay. All right. So you're saying I copied the whole column. Yes. Now this is what we have, right? For me to be able to determine which of them actually is the unique code. Unique code means what? This one must be unique. It must not be what? It must not have any duplicate. So we have 71. 71 should only be representing this suburb and this city and so on like that. So we should be doubting. So if we can check, so generally I'll just highlight all of them, right? And go to my, I will need, what I want to do is to remove duplicates from all the columns that we have there. Yes, under data tab, I'm currently on the data tab, then you remove duplicates. Yes, from all the columns. From all the columns, remove duplicates. And tell me that what? It has removed 7,891 duplicates. Interesting. Okay. Now, I now need to what? For me to know, so I need to use the conditional format to highlight what? Any row that has what? That has duplicates. So conditional formatting, highlight any cell that has what? Duplicate values. Duplicate values. Now, easily, I can now what? So we can see suburb cannot be the duplicate. Yes, address actually cannot, it doesn't have duplicate longitude and latitude. But yes, city, yep, suburb. Now, on our postal code, this is the major reason why we cannot use postal code, because postal code is already showing us what postal code has duplicate. Let's further confirm it. For postal code, now we need to what? Filter. We filter by color. We need to filter it by this particular color. Then we see what happened. Let me first filter it from now smallest to highest. Now by default, we can see that postal code 112 belongs to the same city, right? Which is correct, but then different suburb. So 112 is talking about Regent. It's also talking about what? Riverside and Paraki. But our primary key has to be unique, which means what? This is the lowest level suburb. So all these suburbs are in the same city. So postal code, definitely postal code is working with city. Just like you having a city and you have a state and you have different city in it, right? So this is the city. Now under each city now we now have suburb under it. So this suburb is the lowest category. Unfortunately, our postal code only deals with city. Same thing when you come to what 604. So for the suburb, it's returning the same value for same suburb, which is not meant to be. This has to be recognized, it has to be identified separately. So, but when you check your region index, so we have 60 for region, 30 for riverside, and 24 for it. In fact, if I now filter down to 60 alone, 60 we should not have any value. 60 should only be representing what we have here, which is the regent. So let me check. 60, filter down to 60. You do okay. Yes, 60 is coming from regent and regent alone, but it can be found under this city, and this is the postal code. So same thing. So same thing for all others as well. Oh, this is where I remove the remove filter. So the lowest in granularity, the lowest thing that uniquely identify every location is our region index. You can use that method. First of all, remove duplicate from all of them, then use what conditional formatting to identify what duplicate values. By default, it's going to tell you that what any column that has duplicate can definitely not stand as our primary key. So here now we can see that what the index is our primary key. So when we come to step 4, index is going to be our primary key. All other ones can be there. And finally, we have the what? Product description. The product description index. So product description index is the primary key of this as well. So this is how you identify all your primary keys. Then another thing to notice, because we are modeling our data, all the different groups that we have here, they are what we call refer to as the dimension table. So this is telling us what we are meant to have 8 different dimension tables. But let's go to the last step of data modeling before we go, which is now to identify our fact table. It is to identify our fact table. Now, fact table now is a combination of all your primary keys in step 4 and the values. And the values. Okay, Abdul Samad, your hand is up. Hello,
Sorry,
Abdul Samad.
please. Yes, sir. I have a question. Going back to
Please go ahead to your question.
yeah, going back to the what's it called, identifying the primary key, the one we did just now. Yeah, yeah, from delivery region text to full address. So instead of just trying to remove the duplicates and then removing the and trying to know the ones that are duplicated in the table, can we just go straight and use features? Like, okay, for now, I can just pick one column, like say delivery region index, and let me just look at let me just look at the values and see which ones are what are unique in the rows. I hope you get my question, sir.
I'm not sure I do. So come again. You are saying we can look at it.
Yeah.
Okay, that's good.
Yeah. What I'm saying is that okay, so instead of just trying to remove the duplicates and the likes, can we just go straight and apply filters? And we can just take one column, for example, delivery region index, and try to see which what's it called, which ones are what are unique in the rows.
Yeah.
I hope you get
okay. So because yes, I do. Yes, I do. Now that will not work. Why? Because you are bringing this from a transaction table. That was where we went to copy it. So by default, for every transaction, what this simply means is for every transaction, they are entering delivery region, the suburb, the city, the postcode, the longitude and latitude, and also the full address for every transaction. So by default, all of them we have duplicates. All columns we have duplicates.
Okay.
Yes, all columns we have. So that's why the first thing is what? We now need to first of all highlight all of them and remove duplicate. The reason why I did this is that so that we won't have no row, complete row will look alike. There should be no row that will look alike. That is because if, for example, now in the normal table, if this person if somebody who is staying in this particular suburb comes to buy something, right? So which means if this person comes to buy 100 times, we are going to be having region index will be 71, suburb will be there, the city will be the same, and so on like that. All this information are going to be repeated like 100 times because it is the number of times this person did a transaction. But what we want to do is want to get, okay, what is even the unique location that we have? So regardless of the number of times you did a transaction, just what? Each row should be unique. So that's why we said, okay, we should not have a row that the delivery region will be 71, suburb with this city, the postcode, and also the same address that will play more than once. No. If it appears more than, it should just go, okay, that even if it's 100, we just need one out of that 100 to represent others. From others to one. So that's why we need to remove duplicate from all the columns first. Now, after removing duplicate from all the columns, we are not sure which of these will serve as our primary key. Then we now need to look using the what do we call it now? That are in conditional formatting. That's the easiest way for me because I understand Excel. For others, they can do sorts. You can sort from highest to lowest, and so sorting from lowest to highest. Okay, then you easily see which one has duplicate. So easily, conditional formatting is already telling me that this particular city has duplicate, and we all know that city is very big. So in a city, you can have as many local government or as many suburb as possible in it. So this must have a duplicate. Suburb 2 is unique, right? Postal code, and so on. So now we can see that for all of them, longitude, apparently we cannot use longitude and latitude. This actually represents the location, geolocation. So it's then the full address. So we can actually, they devise a means for identifying each location, which is the region index. No duplicates, nothing. And then actually it means it is unique because your dimension table, your primary key must always be unique. Whenever I say OPS across the organization, OPS must not mean two things. It must just mean what? Operations. It must not be operation and at the same time mean another thing again. Then it's no longer unique. So that's why we need a unique value. So that filter that you made mention of, yes, it will eventually not work for it. So that's why we will not be able to use that, and we use this. Does that answer your question?
Yeah, it does. Thank you.
Yes. All right. Thank you. Then finally is to identify the fact table, right? Fact table means what? All the primary keys that we have here now. So remember I say what? Primary keys, when they get to another table, they become a foreign key, right? So all the primary key that you have here, so you just bring them back as well. You replicate them. After replicating all the primary keys, then these values that we have initially, value will become what? You just come and add your values to it. So this step 5 now is going to be our dimension table. Our fact table, sorry. It's going to be our fact table, which is now going to be the main transaction table. The main transaction table. Now, instead of having how many columns? Instead of having 21 columns that we have on our denormalized table before. Now, how many columns do we have here? I can do count A to count it. How many columns do we have? We now have 12. Now, can you see now? We have in our transaction table now, it will no longer be 21 columns. Rather, we will now be having 12 columns. And once you have these 12 columns, then what you can now do your report across. So you have a 12 columns for your fact table. Then we are going to be having separate dimension tables. All these are dimension tables. And we'll say what dimension tables, fact tables contain the key metrics of the business. What and what in your fact table you have the primary key. Now all these primary keys that are in the dimension table, when they get to the fact table, they becomes what they are referred to as the foreign key. So they become a foreign key. And like I said earlier on, foreign key is just a primary key of one table that can now be found on another table. When they get to another table, they automatically we refer to it as a foreign key. So that is how you model a typical model of what of your table. Now you can now go to Power BI and replicate everything that we have here on your Power BI. So you're going to have multiple facts table, multiple dimension tables. Why do I keep mixing this up? Multiple dimension table and a fact table that will be connected to it. And eventually, you can create your connection. And eventually, when you are able to now connect all your tables, you're able to connect all your tables in Power BI. So you create a relationship between the tables. And once you have created a relationship between your tables, then you can now start what? Doing your report. And one good thing about creating a dimension table is you can always increase your analytic power. You can always increase your analytic power. So let's quickly go and replicate this, what we have done here in Power BI. Then we wrap up there. All right, where's my Power BI? I have Power BI open. Really take much of our time. Sorry for taking your time. It is not my doing. Okay. All right, so I think I have one. This I was looking at. Really? So if I connect to this table now, maybe in subsequent class, so we can connect to this and create our facts, our star schema relationship. And maybe in subsequent classes too, we can also look at what will necessitate you to have a snowflake schema. So the same way we are going to put, we are still going to model it, then we'll see how it becomes a snowflake for us, maybe in our subsequent classes. I don't know if we're having the time. Okay, now let me break up my Power BI now. So because we have already sectionalized it, we know what will be our fact dimension table and what will be our fact table. I can then go ahead to connect to the data. So let me go to, it's on my desktop. What do I call the file? Something Power BI data model. Yes. Connect to it. Gakpelumi, well done, welcome, sir. Okay, I'm connecting to this now. Transform. So what I did was just first of all visualize how this table is going to work. What are the dimension table that I'm going to have, and what will be the fact table, and what will even be the content of my fact table. That's how I have to do it first in Excel, and then I can transfer whatever I've done in Excel into Power BI. Now, yes, so because we say we are going to break this table down, so first thing is let me duplicate this table like 5 times first. Duplicate, duplicates, just duplicate like 5 times. Before I start, okay, let me do one more. Duplicate. So first thing is we need to first of all identify all our dimension tables. So we need to create our dimension tables separately. And where are the dimension tables? Now, all this grouping, So first dimension that we have is G1, which is the order number. Now in this, order number simply means for every transaction, you're going to be having an order. So because this order keeps what? Increasing at all time. So it is best to leave it in your fact table and not create a separate dimension table for it. For every order that somebody makes, we generate a unique ID for it, right? So it is best, since it's a systemly generated this thing and it's going to be generated at all time, then just leave it in your facts table. So there's no need for creating a dimension table for this. Now, order date and ship date, yes, we're going to do this, but then we create a separate date table in Power BI. So let's leave this for now. I love the best thing is to create your own date table in Power BI. I think I might show us before we leave. Now, the group 3 is where we have what? Just the customer name and the customer index. So if I go to my Power BI now, so I'll call this my customer table. Customer. All I need in this table is just my customer name, customer index, and customer name. Every other column, they are not needed. So I'm going to right click and remove other columns because they are not needed. And again, remember, this is coming from a facts table. So it is possible that what we have these numbers replicated. For example, now 28. If I go to 28, you can have 28 as many times as possible, which is the same person, because of the number of transactions this person made. But in the recent, we are not interested in this. Just what 28 for Dama Limited alone. That's all. So we need to remove duplicate. There should be no duplicate in your dimension table. On your fact table, yes, you can have a duplicate because it represents the number of times somebody comes to make a transaction. But your dimension, there should be nothing like duplicate. So you can come here, just like the way we did it in Excel. Yes, then you remove what? Can remove duplicates from the table. I think I normally do the fastest one. Click on this. This icon was what I clicked on, this table icon. Then remove duplicate. Where is it? Okay, remove duplicate. It tells me to remove the duplicate. Then once I filter down to 28 now, which is the Dama farmer, I should not have more than one. You can see Dama farmer. So remove duplicate. So let me cancel this step. So now our customer table is intact. Let's go again. What is the next table? The channel. Yes, channel of distribution of our products. So we have different channel, right? So we can create it. Yes, we can create. Channel is just standing alone, right? But I can create a dimension table for channel. So I'm interested in something. When I go to channel, then remove other columns. And from channel as well, you need to, there's no point in having also repeated multiple times. Just say remove duplicates. Yes, we have just channel and we have 3 things there. Channel. There is I'm doing this. Then the next one is for currency. I'm not going to create a separate table for currency. Currency. Yeah, currency is next one. We leave currency. Now warehouse code. Let me go and create for warehouse code, because the thing is, any column with just any table with just one column, there's no need to create a separate table for it. You're just wasting space. But if there's possibility that this particular column we have some attributes later, then you can create it. So that's what I actually want to show us here now. Our warehouse now is the only thing there. So remove other column and remove duplicates. Remove duplicates. Then I call it my warehouse. My warehouse. After warehouse, what do we have? We have delivery region, suburb, city, that's the G7, talking about location. So if I go back to Power BI now, on this one, this particular table, delivery region index, up to where I have the full address. The full address, right? Those are the columns I need. So remove other columns and remove duplicates. Remove duplicates. So this I can call it the location. Yeah. Then I go to the next table. What do we have there? The product information G8, which is the product index and the product name. Product index and product name is what we need for this particular one. Okay, products index and products name. Then remove other columns and always remember to remove duplicates. Very important. So I can call this one now my products table. Right now, we now have, so the last one, which is the main one, the sales data table now, will now be our fact table. And remember, fact table is meant to be what? Combination of all our primary keys and values. Primary keys and values. So I can just say in this. So I have my Power BI beside it. Now, what are the primary keys? I need the order number. So easiest thing to do is I'll just go to transform tab and okay, home tab, where is it? I want to choose column. Yes, manage column, choose column. So it is very easy for me. So here and I can just untick what we do not need. What we need, I will leave it there. So what do we need? We need the, let me see now. Order number, yes, we need it. Order date, yes. Ship date, I will leave that one as well. Customer index number, yes, we need the customer name. No, we do not need it. The channel is in the primary key, yes, we need it. Currency code, yes. The warehouse code, yes. Delivery region index, yes. Suburb, city, postal code, longitude, latitude, and full address, we do not need them. So that I'm going to on what uncheck them. Let me even remove the ship date. Okay, let's go. There's a reason why I don't want to remove it there, because for every transaction, your ship date is going to be put there. It's going to be different. So it also grows, ship date grows at all time as well. Product description index, yes. Product name, I don't need it. Then every other thing, I need them. Click on OK. So it has removed all the columns that are not needed. So here now, I have just what? 13 columns. 13 columns. Now, before I load, when you have your dimension table, the expense of it is it helps you to increase the analytic power of your reports. For instance, now here we only have the warehouse code. You can add more information to this, like the warehouse, name of the warehouse, what exactly is the name of that warehouse, who is the manager, the team in charge, and so on like that. So you can add multiple columns to it. So I can add a column now and say conditional column. What am I saying? Cancel. I say conditional column is what? If the warehouse code is what? AXW291. Yes. Oh, AXW. Then it should be called what? It should be called, let me borrow name. I do miss. Okay, it should be called Lagos. That's the Lagos warehouse. Again, if it is GUT 930, that is what? That's Abuja. That's Abuja. If the code is NXH 382, right? This should be what? This should be Kano. And the third one, the last one should be the Port Harcourt. So Port Harcourt. Now I'm now adding information to this. In fact, I can even say, okay, for this now I can assign the manager to them by adding what? More column and say conditional column. Yes, for those what this one now, if it's Lagos, who is the manager? I want the manager to be Balumi for Lagos. Okay, so custom. I've not changed the name for Lagos and Abuja actually. Abuja should be Sodiq is the manager. For which column again? For Kano, the manager should be, who am I using? Let me use a star. And for Port Harcourt, let me use Samad as the manager. What are we doing here? I'm now increasing, that's the manager column. Okay, what I'm doing here is what? I'm increasing the analytic power of my dimension table. This is the warehouse. Warehouse. And both columns should be in text. Change type. So we can increase the analytic power of your dimension table by adding more columns, more information to it. Same thing. But let me load this and pop. 1 hour is becoming 2 hours. Imagine. Apologies. Now that I've loaded all the tables into my table is still loading. Once the table is done loading, then I can now what? Create a relationship between my tables. And what are we doing? We are trying to connect all our dimension tables to the fact table. And the kind of relationship that you can create, we have different relationships that you can create. You can create what we call the many-to-many relationship. We have the one-to-many relationship, or the many-to-many relationship, or the many-to-one relationship. So all these determine what is dependent on which table is filtering which table. Okay, now we have all the tables are loaded, and on my model view, you can see by default this has been done. You can see now we have this table has been created already. Dimension tables has been connected to our fact table. And what happened? So we have different types of connections. So if you look at this now, in between the product table now, you can see a 1 there, and fact table you have star. This is saying that what? This is the one side of it, and 1 means 1, then star means many. So this type of relation is called one to many relationship. And it's also the same thing as many to one relationship. So you have one-to-one relationship, you have to be many one-to-many relationship, and we also have many-to-many relationship. And so by default, you can see, because I didn't create this relationship myself, Power BI already automatically detects it. So this is done on my Power BI settings actually. If I go to file and go to settings and options and settings, whatever it's called, you go to options, then when you go to data load, under data load, it is loading. Yep. Data load. Here's my data load. Now I can set that and say, now by default, automatically detect new relationship after a data has been loaded, because this has been ticked, then it actually did that for me. But assuming this was not ticked, all the table will just be brought in, and I'll have to create my relationship myself, right? And how do we even check the relationship? Once you click on the line, you will see what exactly is connected. What is connected? If I click on the line now, over on the line, warehouse on the warehouse table is connected to what we have here. It's connected to what? Okay, this table is longer. Can expand it. Warehouse to. If I bring this table downward now, you see that it is connected to warehouse itself. So it's very important that you always check the connection. In case there's any error, you can always what? Change the connection. So you create a relationship between your tables, and you can now proceed to start what? Creating your report. So it makes your report very, very, very easy. And one of the best practices for data modeling is what? When you are creating your data model, there are some things you need to look out for. Number one is before you model your data, you must already you have pictured what you are the end solution. What will the end solution be? So you start with the end in mind. So what will be the end result of what I'm doing? You must have pictured it. Also, you should be logical about modeling your data. And it is best to use the star schema model. And also, your data type is very important. One of the very important things is what use the right data type for your each column. So check the data type and make sure they are of the same data type. And your naming convention has to be use something that can easily be understandable. Also, you what whenever you and this actually remember one of the importance is that it makes it easy to create your measure, but it is preferable that you prefer measure over calculated column because calculated column will create a column on your table and which will also what take some memory space in your data. So in order to increase efficiency and performance of your work, you what create measure because measures are stored in the system memory, not on the table itself. And always make sure you test your model. They are very, very, very important. So today we are going to be stopping here. And if you have any question, please you can ask me before we finally call it a day. And to our Muslims, because they need to go at we've actually gone 41 minutes beyond. And that was because people did not join on time. And we have a lot to cover actually. So thank you very much, everybody. Any question before we call it a weekend or a month? Thank you, thank you, thank you. All right. So in the absence of any question, then we can call it a day. And if
sorry,
okay, Samad,
last minute, yeah. Going back to the dimension table, you said it increases the analytical power of our report, right? So is it that if we're having like one column, right? So are we going to just assume and put something there, or what? Like
no,
I see, like
we are
we're just
not
trying to.
assuming. So yes, so what I'm trying to say is, as at the time that we created, so before even we have already modeled our table, right? So later on, if we now have a new classification that we want to be reporting by so and so is dependent on what we have on this particular dimension table. So it is very easy for you to just go there, increase add that column to it.
Okay.
You understand? Yes, we are not just assuming. So our business now need a new way of reporting. We need be based on industry trend. So I think people it is best that we start reporting by this particular metric, but it is not in our data before. We didn't make preparation for it. But then because we have already modeled our data very well before, and this metric is based on and so that we already have on our a column that we already have on our dimension table. Very easy. You can easily add it to it, and it will not even eat many space because it's just adding like 5, maximum of 10 or 20 new rows into your data. Unlike when you now take it into the main dimension, when you have a denormalized table that you now need to add it, that will now be like millions of rows that you are now adding to it again. Do you understand? So yes, that's what we are talking about. Yes.
Thank you.
Yes.
Thank you so much.
All right, you're welcome. And please, if you have any question, even after now, probably after we are done for today, something comes to your mind, you can always drop a question in the group chat. So somebody will respond to it. Thank you very much, everybody. Bye for now. See you in the next edition of our monthly.
Before you go, Morga, good evening.
Believe me, what's the issue?
Before you go,
I'm here.
Yeah, I'm really sorry for joining late. I actually slept off. So thank you very much for today. Yeah, bringing you down here is not something easy. Yeah, thank you very much, and thank you for joining as well. So for those that join, I can see that we are just 7 on the call. Yeah, it's good, but it's not encouraging because this is Sunday. Sodiq should be using his weekend to either sleep or rest before we'll start the goals of next week or this week work. So I really want
or
us
even attend parties.
that's another thing. So I really want us